In this video, we're going to talk about how to determine the minimum distance between two objects in 3 dimensions. So suppose Skippy is flying an airplane that's currently right over his house. His altitude is 4,000 meters and his velocity is 60 kilometers per hour due north. At the same moment, Charmaine is 20 kilometers due west of Skippy's house. Charmaine's altitude is 2,000 meters and her velocity is 30 kilometers per hour due east. Charmaine is climbing at 50 meters per minute. We want to know at what time t the planes will be closest together and what the minimum distance will be. Well, it's much like the distance formula questions that we've done before. We can think of east and west movement as movement along the x-axis. We can think of north and south movement as movement along the y-axis. Movement to the east is positive movement along the x-axis, and movement to the west is negative. Movement to the north is positive along the y-axis, and movement to the south is negative along the y-axis. The added dimension here is literally an added dimension. We have movement along the z-axis. We can think of the ground as having a z-coordinate of 0, and movement up is positive along the z-axis, and movement down is negative along the z-axis. Instead of each point being an ordered pair, then, each point will be an ordered triple. And we need to determine what our unit of measurement will be with respect to both distance and time. The distances in this question are measured in kilometers and in meters. So we're going to measure in meters, and the time is measured in minutes and hours, so we're going to measure in minutes. Usually we pick the smaller measurement each time. Now we're going to let the origin be Skippy's house and time t equals 0 be the moment that Skippy is right over his house. Now, since Skippy is right over the origin, his x and y coordinates are both 0. But his z coordinate will be 4,000 because he's actually 4,000 meters above his house. So Skippy's initial position will be 0, 0, 4,000. Now, Skippy does not move east or west, so his x coordinate's going to remain unchanged. However, also he does not increase or decrease his altitude, so his y coordinate will remain unchanged. However, his I meant to say his z coordinate will remain unchanged. However, Skippy's moving north. That's a y coordinate movement, and movement north is positive. And so we're going to say that his y coordinate increases as a function of time. Now, 60 kilometers times 1,000 meters per kilometer is 60,000 meters. So his y coordinate is increasing at 60,000 meters per hour. But we want to measure in terms of minutes, as stated earlier. So we're really going 60,000 meters per 60 minutes, and that's like saying 1,000 meters per minute. So what's really happening is Skippy's y coordinate is starting at 0, increasing at a rate of 1,000 meters per minute. So we're going to say that at any given moment t, his y coordinate is 1,000 t. His x coordinate, as stated earlier, is 0. His y coordinate is 4,000. Now, the origin, as we said earlier, is Skippy's house, and Charmaine begins 20 kilometers, i.e. 20,000 meters west of that. Her initial x coordinate is therefore negative 20,000 because west movement is movement to the negative regarding the x-axis. Now, Charmaine's neither north nor south of Skippy's house, so her initial y coordinate is 0. She begins at an altitude of 2,000 meters, so her initial z coordinate is 2,000. Now, she moves 30 kilometers per hour due east. That means her x coordinate is increasing. 30 kilometers is 30,000 meters, so she's moving 30,000 meters per hour. There's an extra 0 there. She's moving 30,000 meters per hour. Now, 30,000 meters per hour is the same as 500 meters per minute. So we can say that her x coordinate's increasing at the rate of 500 meters per minute. Since it starts at an x value of negative 20,000, her x coordinate is actually, at any given time t, negative 20,000 plus 500 t. I'll just reorder that and say at any given moment t, her x coordinate will be 500 t minus 20,000. Her y coordinate never changes because she's not moving north or south. Her initial z component's 2,000, but her altitude increases 50 meters per minute. So that means her z coordinate is going to be 2000 plus 50t. I'll just rearrange that. I'll call it 50t plus 2000. So at any given moment t, her position will be given by 500t minus 20,000, comma 0, comma 50t plus 2,000. Now we want to determine the value of t when those points, S is regarding Skippy, and C is for Charmaine. We want to see when they're closest together. And the formula for distance between 2 points in 3 dimensions is very comparable to the formula for 2 points between 2 dimensions. We just keep the formula the same, but we also add in an extra z2 minus z1 quantity squared underneath the square root. So plugging in our components, we'll say C minus S, we have 500t minus 20,000 minus 0 right here. And then we have 0 minus 1,000t right here. And we have 50t plus 2,000 minus 4,000 right here. Okay, now in the next couple of lines, we're going to do a little bit of simplifying. When you say 500t minus 20,000 quantity squared and 50t minus 2,000 quantity squared, you're really saying in the next line, put them next to each other and expand it out. So that's what we're doing here, okay? So when you expand out, you literally have to do all these steps, distribution property like you learned in grade 9 and 10. So after doing all that, keeping it under the square root, of course, you end up with this long expression here, and then ultimately we collect terms, and we get square root of 1,252,500t squared minus 20,200,000t plus 404 million. Now, we know that our time is between 0 and infinity, so we're going to use the chain rule here. We're going to say that d prime of t equaling 0 would imply, using that chain rule, that 1/2 times this whole quantity to the exponent negative 1/2 times the derivative with respect to t of that quantity needs to equal 0. So we have that written here. Now, what we can then do is multiply both sides by the denominator, and then we can solve. Move the 20,200,000 over to the other side, and dividing both sides by 2,505,000, we get that t is roughly equal to 8.064. So d at 0 is approximately 20,100. 20,100. D at 8.064 is roughly 17,960. Now these represent meters, so at a time of t equals 0, the two planes are 20,100 meters apart. At a time of t equals 8.064, they're roughly 17,960 meters apart. And considering the expression inside the square root, we see it's a quadratic function with a positive leading coefficient, and we know that the end behavior as t goes to infinity, this expression inside here will also go to infinity. Square rooting that doesn't change the fact that its end behavior is still heading towards infinity. So basically what we're saying that is as time goes to infinity, the distance between them will also go to infinity. And we actually kind of intuitively know that. So this is just in case a question like this did not say to you that you're suppose a question wants you to consider the domain x point, the domain values. You'd plug in a t value of 0. You'd also plug in a t value of infinity, but since you can't actually do that, you would take the limit as t goes to infinity. And intuitively, you know, as time goes to infinity, these two people are going to be very far apart. So we know that's not the answer. So based on all the above, the planes will be closest together at roughly 8.06 minutes. And the shortest distance between them will be roughly 17,960 meters. Now, a second method here is what people sometimes do instead is they just square the distance formula. So instead of doing everything we just did, they square the distance formula, and they say to themselves, you know what, whatever value of t it was that maximizes the distance, will be the same value of t that maximizes the square of the distance, because distance is positive. And so they square d of t, and squaring something under a square root when you know it to be positive is just, the inside of the square root. And now we can set that derivative equal to 0. Setting that derivative equal to 0 gets us to the exact same value of roughly 8.064. And now we would be, of course, plug the 0 and the 8.064 directly in. You don't have to plug the 0 in if the question tells you that you don't have to consider the n values of the domain. But in this particular question, we'll assume that it didn't allow us to ignore that. So we plug in time t equals 0. We see the distance between them, as mentioned a few minutes ago, is 20,100. We plug in a t value of 8.064, and we get 17,960 as the distance between them. And again, for the same reason stated earlier, you can't actually plug in a t value of infinity, but you can determine a limit as t goes to infinity. And doing that, we get that it's infinity, and the square root of the square root of a number going to infinity itself goes to infinity, so that the limit of the distance itself is infinity as well. So based on all the above, we see that the planes are closest together at roughly 8.06 minutes, as stated earlier, and the shortest distance between them is approximately 17,960 meters.